Homology is one of those mathematical concepts which are technically really complicated, but the intuition is absolutely simple. In fact, homology is nothing else but a game of Chinese whisper. We take 3 children, Alice, Betty, and Cecilia. Alice tells Betty something, and Betty tries to pass it on to Cecilia. But there's some information that gets lost at Betty, because it's a game of Chinese whisper, right? In homology, we want to know how efficient Betty is at, number 1, getting information, and number 2, passing on the information. So what we do is we take the incoming information in relation to the outgoing information. In mathematical terms, these are called differentials. We have A going into B going into C, and we have maps differential delta A and delta B. So what we do is we want to find the relation between delta B and delta A, so the information that Betty passes on versus the information that Betty actually gets. The information that Betty gets is what we call the image of delta A. So the image is the set of elements in B that are mapped onto by the differential delta A. In the outgoing map, we look at the so-called kernel. So we're looking at all the information that gets lost when Betty talks to Cecilia. And in mathematical terms, these are all the elements in the set B that are being mapped onto the 0 set in C. And in order to put these into relation now, we build the quotient. So we mod out the kernel of the outgoing map over the image of the incoming map. And this is how we measure how efficient Betty is at receiving and passing on information. If Betty receives perfect information and passes on perfect information, so there's absolutely no loss of information in this line from Alice to Betty to Cecilia, then we say the homology is 0. So homology measures how much information gets lost. And what we actually have in mathematical research in the area called algebraic topology is not just 3 kids playing a game of Chinese whisper, but an infinite amount. So we have an infinite row of maps that go in and out of certain points. And we take homology, so we take this relation at each of these kids, at each of these points, and then we measure the entire flow of information. And it is a very powerful tool that really helps us to understand complicated objects in a deeper way. Homology is one of those